Today we will be looking at a question from the 2011 AB exam. I've classified this as type 2 because it's a particle in motion, so we're going to be looking at position, velocity, acceleration. And the information provided is from time 0 to 6, the particle moves along the x-axis, so it's moving kind of left and right. The position is not explicitly given, but we do have the velocity equation as well as the acceleration, and we have an initial position. So in part A, they're asking, is the speed of the particle increasing or decreasing? So we should recall that speed is increasing when velocity and acceleration share signs. So this is going to ask us to evaluate the velocity and the acceleration and see if they're sharing signs. So at time 5.5, we're going to evaluate v of 5.5 and a of 5.5. And if these have the same sign, then we need to say that the speed is increasing. So grab a calculator and we can evaluate these two things. Okay, I'm going to use the y equals for evaluating in case I need to use these functions more than once. So 2 sine of e to the t divided by 4 plus 1. So I'm using the variable x because we're in function mode, but it'll still evaluate the same. And instead of writing divide by 4, I just put 0.25. Okay. The acceleration equation is 0.5 e to the 1/4 t times cosine of e to the 1/4 t. So we have our two equations, velocity and acceleration, and we want to evaluate both of these at 5.5. So if our table setup is set independent to ask, when we go to our table, we can delete out any values in there and type in 5.5. And we get two values. Both of them are negative, so we now know that the speed is increasing. So v of 5.5 is approximately negative 0.45337, and a of 5.5 is approximately negative 1.3585. So both of these are negative, so the speed is increasing. Both of these are smaller than 0. Okay, that's part A. Part B, they ask us to find the average velocity over the interval 0 to 6. So average velocity, there's two ways we can do this. If we are given the position equation, we can do position at time B minus position at time A over B minus A. If we're given the velocity equation, then we can do the average function value of velocity. And these are different approaches. They will yield the same result. And in the case of our problem, we do not have the position equation, so we're going to use the velocity approach. 1 over 6 minus 0, integral 0 to 6 of v of t dt. And again, because this is calculator active, we can turn to our calculator to find out what this is. So quit to our home screen. 1 divided by 6. Actually, if you do the fraction, alpha f1, we can do a fraction, 1 divided by 6. And then integral would be math 9. Gives us the integral, 0 to 6. And then I stored velocity under y1. So by pressing alpha f4, I can pull up my y menu, y1 dx. And we get a average velocity of 1.949. All right, moving on to part C, total distance traveled. So total distance traveled is going to be the integral from A to B of the absolute value of the velocity function. If we ignored the absolute value, it would be total displacement. So I'm going to write that here. They don't ask for this, but displacement is very similar looking, but this accounts for negative direction, whereas this is just adding up the magnitude of all of the direction, regardless of whether you're moving left or right. So we're looking for total distance. So we want to do from 0 to 6 of the absolute value of v of t. And again, we can use our calculator on this problem, so all we need to do is know how to type in absolute value. So Math 9, pull up the integral, 0 to 6. To pull up absolute value on the calculator, we press Math, and then we scroll right to number. There's the absolute value command. And we're doing the absolute value of velocity, which I stored under y1. So by pressing alpha F4, it'll pull up the Y menu. If your calculator doesn't do that, you can also do it by the vars menu by pressing vars and then scrolling right to yvars, selecting function, and there's y1. So that's another approach for that. And we're integrating with respect to x, even though the paper it's t, but the calculator doesn't care. So with respect to x, takes a little bit of time, particularly because it's got this absolute value that it's thinking through, and the equation isn't a very straightforward one. But we get there, 12.573. So approximately 12.573 units. Total distance. If you get a negative answer here, you know you made a mistake because there's no such thing as negative distance. And then finally, part D. The particle changes directions exactly once. Find the position of the particle at that time. So, change directions. When v of t changes signs. And that would mean we need to find the time where v of t equals 0, because the particle is moving on a continuous curve, so when it passes through 0, the sign of velocity will change. So we need to calculate when does velocity equal 0. And again, because this is calculator active, we can turn to our calculator. Looks like y1 is our velocity. So if we graph y1 on the window from 0 to 6, we'll see the curve come, and eventually it should change signs. And it looks like it does it really close to time 5 seconds, but let's go ahead and move over and see exactly what that is. So second, calculate. Oops. We want to find the 0 of the function, so option 2. And it looks to be pinned between time 4.5 and 5.5, so I'm going to make my left bound 4.5, enter. Make my right bound 5.5, and then enter. And then my guess is somewhere around 5. Does some thinking, and we get the spot where it is 0. That's a valuable number, so I'm going to store that as a variable. So if I go x store under a, we now have that stored under the letter A. So at t is approximately 5.19552, which I'm calling A. So now we know the time that it changes directions, and they want the position at that time. So the position at time A is equal to the position of where I started plus the accumulation from start time to time A of the rate of change of position. This is the fundamental theorem of calculus rewritten. What I have is equal to what I started with plus what I accumulated. So x of A is equal to the position they give us at time 0 is 2 plus the integral 0 to A of x prime is the same thing as v of t dt. So this is what I want to type into the calculator to find the position at time A. So math, 2 plus math 9, 0 to, I call that time A, and then my velocity function is still stored under y1, so alpha f4 pulls up the y1 dx. 14.134. X of A, the position when it changes direction is approximately 14.134, or if we round, 14.135 units to the right of the origin. All right, so let's look at the grading for this. Part A is worth 2 points. 2 points. The conclusion with a reason. So the reason is acknowledging that speed is increasing when velocity and acceleration share signs. Part B is worth 2 points. You get your first point for recalling that you need to take the integral of velocity, and you get your second point for having the correct answer of 1.949. Part Z is also 2 points. This is knowing that distance is the integral of the absolute value of velocity, and then the second point comes from the correct answer. And then finally in part D, this is worth 3 points. If you consider that the velocity equals 0, so recognizing that something important is happening there gives you the first point. Your second point comes from taking the integral of velocity. And then your final point out of the 9 comes from having the answer. So, all right, be sure to smash that like button, comment, subscribe. Have a good day. Thanks for watching.